Hello, welcome to your third video in Chapter 7. We're going to talk today about hyperbolas. Now, I've given you a little picture right here, and I am going to get my finger out of the way here, and I want you to take a picture of this if you want to, or just take a screenshot. And then you can write down a lot of this vocabulary later, because I'm going to go through it a little quickly right now, and then I want you to write it back in your notes. But first I want to just show you what this picture is, and you can see these blue, they look like parabolas, all right? Well, both of them together make a hyperbola. And a hyperbola is the set of all points that the difference, the distance between the two fixed foci right there and their distance from the center. So you still are going to have vertices, what we would think of as a vertex or of the parabolas, and that's still going to have a center between them. It's still going to be our H and K, and you're going to have a major, what you would think of as the axis of symmetry. We're going to call that now our transverse axis, and that distance from the vertices to each vertice through the center there is distance of 2a. So a is always our major axis when we're dealing with hyperbolas. And the conjugate axis was what we would think of as the minor axis, and that would be a distance 2b. So you still are going to have the distances a and b similar to what we did with the ellipse, but now you're going to have the A is always going to be the transverse axis. It's always going to be the first number in the equation. It's not always now just the larger number. As I said before, you have two branches. You have these two branches of the hyperbola, and they may also be going vertically instead of horizontally. This is the vertical one. You may have the horizontal. We'll look at that in a minute. Now, I want you to look at these red lines. They are asymptotes, and the asymptotes are actually going to be used to frame the hyperbola. And you're going to make the asymptotes be diagonals of a rectangular, of a box here that we're going to make with the A and the B. So I just want you to kind of get a visual image of this before we start jumping in and tackling the specific types and the specific parts. So again, I'm going to get my hand out of the way. I want you to freeze that, take a picture of that, and write that vocabulary. Now we are going to specifically, and if you copied the note sheet, that's great. If not, then you can just write this in. But we are going to do some specifics with regards to the vertical and the horizontal components of the hyperbola. So first of all, these differences in the equations, let's look at the differences. You have, both of them have the a squared first, all right? They both have a b squared, all right? They both are, as we mentioned, a difference. They are subtracted, okay? But I want you to notice something, that when you have a vertical hyperbola, which is the picture I just showed you a minute ago, when it's vertical, you're going to have the y first. When it's horizontal, you're going to have the x first. And that's going to be a very big clue. When it's vertical, your y term is positive, the x term is negative. When it's horizontal, your x term is positive and your y term is negative. Okay, that's going to be important. And the center is always going to be at H and K. Your vertices are always going to be an A distance from the center. Now, some of this was also in the vocabulary. Your transverse axis is always a distance of 2a, and your conjugate axis is 2b. Now your asymptotes, we'll get into that in a minute when we're drawing that. So let's first try to map this out a little bit. Let me get my pencil, which I cannot put my hand on right now. All right, here we go. So when we sketch this out, you are going to, first, I'm going to do an easy one and make my center at the origin. And then I'm going to come this is vertically a distance of A. So I'm going to come up a vertical distance of A, and I'm going to go down a vertical distance of A. So I'm going to call that A. Now I'm going to come horizontally a distance of B. Now A does not have to be the larger number. All right, so let's come out here to about the same distance. I'm going to make that B. Now you're going to get those 4 dots and you're going to make a box. You're going to make a box because you want the diagonals of that box. And I usually start in my center and I go to the corners. It just makes it a little bit easier. There are your asymptotes. Your asymptotes frame the graph, because now if I know it's vertically, my y is first. I went up A on my transverse axis. Here is my hyperbola. Right there. And it kind of hugs those asymptotes. Down here, it's going to come across like that. So, a couple things that we can label. Here is a vertice. That is a vertice. What you would think of as a vertex, but you have 2 of them, so they're vertices. Now our foci are again inside where you would think like the parabola, the focus was. So here you have a focus. Here you have a focus. And that distance to the focus is C. All right, so that distance is a distance of C. And you have this distance of A. So before in the ellipse, when we calculated the foci, remember it was C squared equals A squared minus B squared. All right, now with the hyperbola, it's plus. So that will be something that you can remember, that difference. And then that way you can always figure out what the hyperbola is and what the ellipse is. You can figure out those foci. All right, so the foci is the C units from the center on the transverse axis. Okay, now your asymptotes. Asymptotes are very easy to get the slope of your asymptote, because if this is a vertical hyperbola, look at your asymptotes. You're going to do rise over run. So this would be A over B, would be this slope. And you can probably guess the horizontal is going to be B over A. So when you write the asymptote equation, and I'm going to write it in point slope, but you're going to have y minus your k, which is going to be the k part of the center, plus or minus the slope of x minus your h. Now here, for example, our h and k is 0 because we're at the origin. But the slope right there, that slope, as I said, like this one is rise over run. This one is A over B. or it's going to be B over A. And we'll see that one over here. All right. This is your transverse axis. This is your conjugate axis. Okay, and I think I don't need to label the asymptotes, you can see those. All right, let's try real quick to get a vertical or a horizontal one done so you can see the difference. So the horizontal one has the positive x value that's squared, and so that value, that A, is going to be along the horizontal axis. So let's come here to A. That looks about the same. All right, and then we're going to go, I don't know, let's make this our B. Well, that's about the same. So then you make your box. You must draw the asymptotes when you're sketching your hyperbolas, so you have to sketch the box. Okay, I made this distance right there B. So, and it does kind of look like a square, but that's okay. Our A and B could be the same. But if there's a subtraction sign in the middle, it is not a circle, it would be a hyperbola. Now, because the x is first, then I know it's horizontal in nature. It's going to be coming this way. All right, there's my vertice. Here would be the other branch of the hyperbola. There's my other vertice. My foci would be somewhere in the middle. Not in the middle, but I mean inside the branches of the hyperbola. All right, this would be your transverse axis. This one would be the conjugate here, conjugate, and this one would be the transverse. How do I want to label that? Let's just come down here. I'll just do it that way. That's the transverse. All right, let's practice some of these and see how we can determine the equation given some of the pieces. But first of all, now that you've done all of the conics, I want to just kind of back up and show you how easy it is to identify the conics given an equation of this form. Now, I have put in your notes this little table here, and this side is used mainly if you are indicating this, if you have this piece right here, if you have an XY term, then that means that you've had a rotation, and there you cannot complete the square. So can't complete the square. So you can't do this type of a problem very well, and to be honest, they don't even put any of these in your book. All right, I really want to focus on this. I want to focus on if I gave you this type of an equation, if you notice that you have two items squared, you have an x squared and a y squared, then if A equals C, if those coefficients of the squared terms are equal, you have a circle, especially if there's a sum. Okay? If you have a sum right there and they're both equal, you have a circle. You have an ellipse if they're both if they're both positive and they have the same sign, so they're both positive, then you know you have an ellipse. If you have a parabola, then one of them is 0. Basically, if you have a parabola, you have an x squared or you have a y squared. So it's kind of nice. If you only have one squared, boom, it's a parabola. Okay? And you don't need to think about anything else. If they have unlike signs, meaning one is positive, one is negative, of the squared terms, then you have a hyperbola. So you really don't even need to look at the discriminant. I know the book will tell you to look at the discriminant, but it is not necessary. You just need to look at the squared pieces and see their coefficients. All right, let's look at an example. I'm going to set this up, and then we are going to do this when you come back in the second video.